So we're back again to another set of applications of what we have learned so far from tensor analysis. This is a very common problem in classical electrodynamics. Here our metric tensor is a constant actually. It's not like the usual ones we have met. This is the same as the eta mu nu here, and in the sense that it could also be used to raise and lower indices. That's what we have over here. Now we want to show that when we can call that the divergence, the derivative of this metric, this energy stress tensor with respect to x nu gives us such an expression as this. That of course we shall see right away. So taking this very quickly, avoiding any form of redundancy, so just command nu, we get this to be equal to. Of course, by the usual Leibniz rule, we have the factor out there, which is a constant, multiplying everything that we're going to be obtaining. We have this to be f mu alpha, comma nu, f nu alpha, plus we have f mu alpha, f nu alpha, comma nu. So by Leibniz rule, the usual thing, differentiate this, keep this a constant, and then vice versa. Minus here, we have 1 all over 4. We've already stated that the eta mu nu there is a constant, so its derivative is 0. So very straightforward, eta mu nu, I'm taking here f sub alpha beta comma nu, f here alpha beta, minus 1 all over 4, eta mu nu again, f alpha beta treated as a constant this time, f alpha beta, but then here comma nu. This is what I get. Well. Okay, here now at this point, we may want to perform some raising. Okay, so I would like to, instead of having to write all this over and over again, you can see that this whole term, of course, except for the minus sign, is the same thing as 1 over 4. If I raise this with this metric tensor, I have alpha, beta, comma, my mu goes up. And here I have f alpha, beta. And the same thing, of course, here is what we have, 1 over 4. Then I have here with me f sub alpha beta, f alpha beta on top, comma. But instead of the nu, it becomes a mu on top. Yeah, that's what we obtain. The minuses, of course, standing where they are. Now, take a very close look at these two factors or terms. So let's just talk about them here for a while. Alpha beta, comma mu on top, and here alpha beta, and then we have another one, alpha, we're dispersing with the 1 over 4 for now, here alpha beta comma, and then a mu here. Okay, first of all, a very simple case is a alpha, b alpha. This is a dot product between a and b. This might as well be written as a alpha, b alpha. We can know this by simply saying if we try to lower this index and then to obtain something like this, I could use a metric tensor g rho alpha, for instance, and obtain a sub rho times b alpha. But then this metric tensor also goes and it could be used to raise the alpha that is here, right? And then if I were to evaluate that, I'll get a sub rho, b rho. Of course, rho, alpha, these are all the same dummy indices. So in other words, we have shown that these two are the same. So I have this alpha, beta, although I have to be careful because I'm dealing with antisymmetric tensors here in the sense that f alpha beta is the same thing as minus f beta alpha. So everything has to be in order of which they occurred. So the raising will be in their order, any lowering will be in their order. So you can see that quite very easily, f sub alpha beta, anyway, someone can say this is the same as being commutative because I'm having f here. It's the same thing, of course, as f alpha beta and then alpha beta down. But it's like a kind of panel beating. You can see that what I have here is, supposing if I decide to push alpha beta on top, I'm doing this naively, I'm not saying this is technical correct, but I'm just trying to illustrate something. If I push alpha beta to the top, I get a factor like this, of course, as the first factor. Then I push this one down, I get this one. So I'm just trying to say that when you have these indices, sometimes even without having to show it explicitly like this, the two terms are the same. If you consider the two indices, especially dummy indices, you can always perform this kind of operation of hand cranking. So in other words, these two terms are just the same. And then for our own purpose, because we are looking at this particular factor here, we might as well consider this to be the same as equal to 1 over 4 f. This is going to be here alpha, beta, like we said. When we do the lowering, comma here mu, and then f, and instead of down, we have it to be alpha, beta. I hope that is not very confusing, and one can just take a moment to look at that again. The whole point is I have minus 1 over 4 of that, minus 1 over 4 of the same thing, and that gives me, of course, minus 1 over 2 of that. So without writing any more expressions, you can see, of course, that the first one is what we have here exactly, and the second one again is what we have here exactly. So this is all good. We have just been able to show the first one. Okay, very quickly, and hopefully nicely also, we want to move straight into showing the second expression. We already have the results that we need to be able to do that. Now in the second expression, what we want to do is to lower this mu. And of course, we intend doing that for every mu that occurs across the expression. So it's simply just looking at this expression, performing some operation that brings the left-hand side to this. Of course, the same operation we have to perform on the right-hand side. So first of all, I can decide, okay, I could have written a term like this, mu nu, gamma, this will be that, nu, comma, nu, right? No. Okay, so looking at this expression, we have that this is G rho mu and T mu, again, sorry, I'm trying, repeating the same mistakes over again. T mu, and I guess this is nu, of course, comma, nu. This is supposed to give me some T, if I were to evaluate this comma nu. However, I'm just trying to find a way by which I can work. So, for instance, let me consider this second tensor here. If I use some tensor G rho mu acting here on T mu nu comma nu, what will this give me? Let me use rho here. If I use this, what I'm going to get is T what? This is going to give me exactly T mu nu comma nu. Exactly. So it's going to give me exactly this. But what's my intention in performing this whole expression? This implies I can divide both sides by this to get that T rho nu comma nu is equal to G rho mu minus, here, this is going to be T mu nu comma nu. Yes. And don't worry, in the end, by the end of the expression, we'll find a way to make rho mu. So, but for now, it's just a simple expression to say that this is that. So, in other words, I can say this is, the inverse of this is, of course, rho mu, T mu nu comma rho. So, what am I trying to say here? In order to find some tensor of this nature, which of course eventually will be this, we'll find a way, like I said, to make that down. To find a tensor of this nature, all we will have to do is to multiply this first expression by something like that. And so, very quickly, we have that T rho nu comma nu is equal to, I simply multiply the whole expression, I have 1 over 4 pi. So I go straight into the bracket. This is going to be G over the rho mu, and this is going to be multiplying F mu alpha comma nu, and then I have here with me F mu alpha plus I have here with me mu alpha F nu alpha comma nu. Oh, sorry, I have to multiply that again. Remember what I said? The whole expression will be multiplied by that. So this is rho mu. So I'm multiplying that by F mu alpha F here, nu alpha, comma nu, and then minus half, of course, G rho mu, again, F alpha, beta, comma mu. Okay, the mu is on top, not down. And then I have here with me alpha, beta. For the first swipe, this is what I get. So how do I proceed now? This time around, I just have to evaluate out the metric tensors and what they will give me. I have this to be 1 over 4 pi, and in the bracket, at this point, I'll simply be lowering this mu, and it will become a rho. So just along the same position, this is going to be a rho, and I have here with me along the side alpha, and of course, I have a comma nu by the side. That is it. And here I have F nu alpha just following us, of course, and that is it. Now, what do I do next? What I do next is plus. I lower again this one here. This is going to be plus F. Instead of the mu being on top, I have a rho down, and this is an alpha here. Then, of course, I have F nu, then alpha down, comma nu. Then minus the last term over there, minus 1 over 2. The mu over here is lower down, so I have here with me F, alpha, beta, comma. Then instead of the mu, of course, I have rho to be down. So that is lowered. And here I have F, alpha, beta. This is what I get. Okay. Everything is just in shape now. Now, what will one do at this point in time? We can decide for starters, like we said, rho is all that occurred here. And we had here initially to be rho nu mu. Okay, rho nu mu. So we can simply, if we desire, just so we can be in conformity with what we have over there. So all I'll have to do again is to make sure I make this kind of change all over the place. F mu alpha nu, F nu alpha plus F here mu alpha, F nu alpha, comma nu, minus here 1 all over 2. I have with me F alpha beta comma mu, and then have F alpha beta, and that is it. Okay. Now excuse me, we're going to proceed by the same method that we did the other time. And what was that method? It's the very interesting method that we have applied previously in one of our operations. The very first term here, for instance, we can try to make to look like this one. And this, of course, again, we can write in a certain manner, just so we can be certain of what we are talking about. We have here some alpha, we have some nu here, and we have to be careful here because the way we have been writing this particular tensor here, the nu is always directly above the alpha. So in other words, this suggests that the nu have taken the first position in that. And those in which we have been a bit slanty, so sorry I've been sloppy. I didn't quite explain clearly the difference between the two. So in that case, it just means, for instance, that the nu being directly upon the alpha means if I am raising this alpha, it has to take the second position. It cannot appear before nu. And we have to be careful about this because F, the field tensor, is an antisymmetric tensor. Now, what about this term? Remember one of the trick I just illustrated here not too long ago with one of the terms we illustrated. Of course, again, it's the same thing over here and alpha here. So one will really have to be very careful about this. It's the same thing here also because the same term here is following us all along. And so what are we trying to say? In this case here, we have a situation whereby, given that alpha is on top here and alpha is down here, is the dummy index. This, for instance, is the same thing as me coming over here, raising. I simply say that this is F okay, mu, and then the alpha comes down here, comma nu, F nu, and then the alpha goes up. So this one comes down, this one goes up. Just like we illustrated before, whatever metric tensor I use to lower this alpha, I will at the same time be able to use to raise this alpha. And in the end, I'm going to have a dummy index, which again I can change all over again to alpha. So this is what this gives me. And of course, this is the same thing as minus of F mu alpha comma nu, and then this is alpha F. I'm taking a minus sign because I'm performing an interchange between these two. I'm trying right away, almost immediately, to be able to obtain this first term. Of course, this is clear to me because you can see already that this is what it should be. Starting here from this second term, that we have been able to obtain the first term, very first term there. Sorry, I think I might have mixed something up. So given this, of course, this is what gives me that. So that is what I do to obtain the second term. The second term here that I'm talking about is this. It's all the same. The only big difference, of course, is that the derivative have been moved over here. Please, I don't want for there to be any confusions with this. Let's just look at it this way. I'll write them both out clearly, and we can see what differences we have in the two, comma nu. So the comma nu is with this. Okay, just quite naively, being or performing the same operations on both sides, this is the same as F here, mu, alpha, comma nu. Then here I have with me nu, alpha. And now, of course, this here is the same thing as F mu alpha, then here F nu alpha, comma nu. Now, on this term, I can perform some sort of, well, you can call that a magic. But then again, just to be in line with what I was suggesting, this is the same thing as minus F mu alpha, F alpha nu, comma nu. I hope I'm not making so much case about nothing here. Yes, we believe that should be the case. And now looking at this one, the very first term, which is this, we have written as that. This very first term, for instance, we could perform an interchange between alpha and nu. Yes, we can. In other words, we can do something like this. Why would we want to do that? Why would we want to make such a transformation? We shall see why in a moment. This is alpha, this is comma nu, this is F nu, this is alpha. And so this is supposed to be equal to, for instance, F mu alpha comma nu, F nu alpha. Then performing the transformation, like I said, between alpha and nu, I get this to be the same thing as F mu nu comma alpha, F alpha nu. Of course, at this point in time, just to be very careful, I can change the nu to beta, so that this gives me F mu beta, comma alpha, this is F alpha beta. Well, it was pertinent for me to have made this transformation on this second term here to see if it conforms with what I have here on the first term. The reason being that, of course, if I obtain the first term, it means I just have to set that aside. And what I know is that I believe whatever is left, I just have to find some way of combining them to see how I obtain what I have here as the last term. That's a combination of all this. So at this point in time, what I have got is this. So this, for instance, gives us the second term. Anyway, I think it's best if I just put it down in the expression instead of making such comparisons. So this is what we get. The first term I'm going to write second. This second term I'm going to write first. And this second term I have transformed into this. And this gives me minus F sub mu alpha. F here, I get alpha nu, comma nu. Of course, the minus sign is there. Now I'm left with plus f sub mu beta, comma alpha, f alpha beta minus half of f alpha beta, comma mu f alpha beta. Yeah. Okay, so let's just continue with what we're doing on this side. Hopefully we shall get, okay, we shall get very close to what we're looking for. So I'm going to take these last two terms out, f mu beta, comma alpha, multiplied by f alpha beta minus, I have over there 1 all over 2 f alpha beta, then there on top f alpha beta. Okay, how do I combine this? Now, there is a reason behind my trying to manipulate these last two terms. The reason behind that is, first, I want to see how I can employ or harness this expression here. Anyway, you can see already that this is already occurring here. So what can I do, for instance? I can write this as, say, this is the same thing as 1 over 2, right? Yeah, of course, this is the same thing as 1 over 2. I think I might have missed something here the last time. This is a comma minus half f alpha beta comma mu. So please, when I said I did that here, there should be a comma mu here. I think that was something I missed. So this is comma mu, then that is still f alpha beta. Now, what I can do is I can say that this is the same thing as half some 2f mu beta, comma alpha, times f alpha beta minus half f alpha beta, comma mu, times of f alpha beta. Right? This is all the same. My reason for doing this is, right now you see I can pull out, or maybe first of all, in order just to be in conformity with some kind of, I can simply, at this point in time, perform an operation on beta and alpha. Or first of all, what I can try to do is to say this is the same thing as half, so I'm performing an interchange between alpha and beta, not strictly on any of the field tensors. So this becomes beta alpha, comma mu, beta alpha. And on doing this, or in doing this, there is no minus sign whatsoever. I've just changed one dummy index into another dummy index. But then when I decide on this particular metric tensor itself, field tensor itself, to interchange alpha and beta, I incur a minus sign on this. It becomes minus half of this beta alpha, comma mu, f alpha beta. Again, why am I doing this? I get a minus sign, which eventually cancels this, so that everything I've written becomes 1 all over 2 again of 2f mu beta, comma alpha, f alpha beta, so that instead of minus I get a plus. It's still 1 over 2. Yeah, of course, the minus here makes it a plus. It's still 1 over 2 f beta alpha, comma mu, f alpha beta. I said, why am I doing this? I'm doing this because this expression, which I said I'm trying to harness here, doesn't have any minuses on it. And then now, to make things very easy, I can say this is 1 all over 2 on the outside. Well, I can put it out here if I like. I have 2 of this, which I can just write as this, comma alpha, plus repeating the same thing again, plus the last one, f beta alpha, comma mu. Yeah. I'll just open up the bracket. This is common to both of them. I pull it out. 1 over 2 is common to both of them. I pull it out. But 2 of these I've written as this plus that plus this one here. Okay, now I think there is something else that I want to do, and which is just combining this with one of these, either this one or this one. And again, this is all in desperate move of trying to make something similar with that. And how am I going to do this? Well, let's just hope it gets well or get better. Let's see. Which one do we attack first? Now I can open up the bracket. Let me just do that. 1 over 2f alpha beta, f mu beta, comma alpha, plus 1 over 2 again, F alpha beta, F mu beta, comma alpha, plus 1 over 2, F here, alpha beta, F beta alpha, comma mu. That's the last one. Now, what do I do, or how do I do to attend this? I think we don't need the details in here. And everything is just fine until this last expression. What do I do here? What I'm trying to do, like I said, either the first term or the second term, take note of this. F alpha beta, F here, mu beta, comma alpha. This is all just some. Well, again, the usual thing we do, interchange between alpha and beta. If I do that, this is the same thing as F beta alpha, F mu alpha, comma beta. Right? That's what I've done. Just that. Again, I'm performing that transformation. I can decide at this point in time to interchange alpha and beta. If I did that here for this one, okay, I wouldn't want to do that for that. I would like to do that for this first two here. I'm going to have a minus, half F beta alpha, but then half alpha mu, comma beta. Now finally, I perform an interchange. In this case, I get half F alpha beta, F alpha mu, comma beta. Have I been helped or have we been helped by this operation? Let's see, maybe not. But we are trying to look for a way to combine these two. We don't have any other dummy indices except that. But looking at these two expressions, we have, for instance, in our terms, we have alpha beta here, and instead of beta alpha. So I guess the operation we want to perform should be on this one. We have this here, and here we have mu beta. In that expression, what we've got is mu alpha. So we could have as well, or could, just like we said, perform it in this case. So what I should have done is, yes, on performing this, we have mu alpha. On this expression, do we have mu alpha? We have mu alpha there. So that is where I would like to stop. In other words, sorry, quite, well, not too much of an egregious mistake. We had, of course, in our previous expression, lowered this mu over here. We lowered this mu in our bid, what we did originally. On lowering mu, we renamed mu mu. Of course, on lowering mu, it became rho, and then we renamed rho mu. And this was what we had. We performed the operation in which we said mu alpha, mu comes down, and this alpha goes up. And of course, if you look closely, you can see indeed that this is equal to that if I simply change. I did that, of course. I just realized now that it was. So you can see that nu changes to beta, and this is what we get. So what I had was this term left and this one. Already we have obtained this first term already, which we stated right from the beginning, as we erased in the previous slide. We already obtained this from the second term here. So what we had was this left first term, which we have manipulated to this and this last term. And you can see that this first term has F mu alpha comma beta, but then F beta alpha on top, and not alpha beta like we had already here. So I'm very sorry, because what I should have noticed or noted then was, in order to have F alpha beta by interchanging the indices on the field tensors, I was supposed to get a minus sign. And I was missing that minus sign. So quite very quickly, this is the same thing as saying minus. So I'm just looking at these two times minus 1 all over 2, and then again times 2 of F mu alpha comma beta plus what I'm left with, of course, if we remember this term, we have also shown using one of our lowering indices. What we did as of then, we had lowered the mu in our expression is what we did, of course. If you remember that, let me just take this quietly because that has been erased. We had performed an operation by saying G mu rho multiplying this comma, nu. And this meant that we also had to multiply this expression here by some g mu rho 1 over 2 of f. And so please, you can just replay this some few seconds back and you see this all over again. And of course, this will mean 1 over 2 g, no, sorry, the g is gone, f alpha beta comma rho of f alpha beta. Then in our own choice, we decided to change every rho to mu. In other words, so I was still making a mistake of putting this mu on top. This, what we have here, is a mu. That was what we did. So in other words, this is plus some f alpha beta comma mu multiplied by f alpha beta, which is common to both terms. So there's a minus sign common to both times, and then there is this which is common to both sides. So in a few moments ago, I missed that minus sign here. And that was because of this mistake that I made in these terms. And this is quite a common mistake in tensor analysis, which is why I'm always very careful with indices. And if you notice in our process and method of lectures here, we have been quite very particular about writing down a lot of things, just so that the confusion doesn't get in the way of making things very elusive. So hopefully this doesn't cause much confusion, but I think from here we can proceed. So the manipulation I was talking about in trying to apply this expression, we can simply go ahead to do right now. Okay, maybe we can do something here. So I've already said this is minus half. Very clearly, this is mu alpha comma beta multiplied by f alpha beta plus. The same thing all over again, because there are two of them here. This is alpha beta, then plus here f alpha beta comma mu, f here alpha beta. This was the expression we obtained, of course, just before we started every manipulation here. As you can see, we are stopped somewhere here. And everything, okay, so of course the same mistake that we had, this originally should have been beta alpha. And I hope that that mistake has been noted. It should have been beta alpha, not alpha beta. It was actually nu, as we can see. We already stated that nu has taken the first position and that it is directly on top of the alpha. So if we are raising alpha, alpha will have to take the second position. That was what we said. Of course, here in lowering, we lowered alpha and it took the second position in this case. If you were to raise mu here, mu would take the first position, and which was why it was slanted. We explained that all already. So now, in our manipulations, as we were saying, looking at these terms, one of the things we can do is just, of course, one of these terms is nothing else multiplying them. So we have f mu alpha comma beta, and we have f alpha beta. So at this point, what can we do? Well, we can just try to make a total interchange between all of them. Here in this case, if I perform alpha interchange with beta, of course, you know what that means. Wherever I see beta, I put alpha. Wherever I see alpha, I put beta. So I get this. And this is going to be beta, comma alpha. This is going to be this beta, comma alpha. Yes, that is what we get. And this is all without any sign change. There is no sign change in this case, and we know why, because all we have done is to have changed one dummy index into another. But now I get a sign change if I perform an interchange of indices on this field tensor. Mu beta comma alpha, then I get f alpha beta. Then finally, supposing I perform an interchange on this term here, what do I get? Again, the minus cancels this minus. Beta mu comma alpha f alpha beta. So I'm just looking at the expression, and this is what I've been guiding me. I have a term here already, which has been manipulated to look like f sub beta mu comma alpha. But also, along these expressions, you can see we simply picked one of them. Let's say this first one. The second one, mu alpha. You can see we have mu alpha comma beta, which is just that. Mu alpha comma beta. Then there is alpha beta comma mu, which is that. So please, I hope all this confusion or whatever it was worth it. Just take a few moments, look at it again, review what we did, and I'm going to try to do that again, just hopefully if I have time in the end. But then, like we're trying to say, I think I can just go simply ahead into substituting It therefore means, let me put that result on top, that what I had before, minus f mu alpha comma beta, f alpha beta minus 1 all over 2 of f here, alpha beta comma mu, and then f alpha beta. This is supposed to be equal to minus 1 all over 2. I think at this point in time, after performing this operation for the first time, as you can see, f alpha beta is restored here all over again. Only this time around with the indices for this one changed. So you can see f alpha beta is common to all three terms. So I'm going to put f alpha beta. Then the very first term I'm going to write to be f sub beta mu comma alpha plus the next one will be f mu alpha comma beta plus I have next f alpha beta comma mu, and that's it. In other words, these last two terms have been combined. Remember, the minus here came as a result of the interchange of this alpha and beta. So you can see that these last two terms have really been changed to that. And the first term, of course, which we obtained from the second term here, is what we have here. So I don't think there's any need going further, because all I will have to do is simply substitute this whole expression for this, and we have obtained this, which was one of the results that we wanted to obtain. Of course, as we move on, we shall see. Anyway, there's no gainsaying that this is 0, which implies, by the way, that this expression, which is t mu nu comma nu, is equal to 1 all over 4 pi minus of f mu alpha, f alpha nu comma nu. This whole expression of term is 0. So in other words, this in essence is actually equal to, I think I should just put minus 1 over 4 pi. Minus 1 all over 4 pi. Yeah. Where this whole term here is 0. So this is what we get. Now, how can we obtain this directly from that? Of course, there are many ways. Sorry. You could have decided to do that from here. But I think I like to use a trick that I already know how to use. But as you can see here, for instance, what do we do here? This looks just like that. You can see, don't mean this is beta, but alpha is here, alpha is here. So in other words, what we've got here is 4 pi j alpha. And that's what we've got. And if we are to evaluate this, this is going to give me simply minus f mu alpha and then j alpha. But that doesn't quite, does it look like that? No, it doesn't. As you can see, what we have here is t mu nu on top, comma j equal to minus both mu alpha on top, and the alpha here is down. Of course, as for the alphas, we know how to deal with that. What we can try to do is, again, what we did before. Remember what we did before? We said you could have, for instance, g sum that, and this will give you rho nu comma nu. If I did that, what I'm going to obtain really is what? T mu nu comma nu. Yeah. If I try to lower this rho, I'm going to have a mu here. But this implies that t rho nu comma nu is the same thing as g mu rho inverse multiplying this expression, which, by the way, is the same thing as g mu rho multiplying t mu nu comma nu. Okay, so I think we are getting somewhere. And this is then equal to minus, because of that minus sign, g rho, and I have here f mu alpha, j alpha. What do I get then? Okay, so now I'm going to be very careful about this. Yeah, of course, we can see, and we're going to be very careful, of course, always. This mu here is the first on this tensor. So if I am raising this, it's going to be minus some f rho, and then alpha takes a position slanted that way, and j sub alpha. Okay, moving forward, it means therefore we have obtained, so I think at this point we are done with everything here. At this point, as you can see, T rho nu, comma nu, we have shown this to be minus F rho, and this is alpha J alpha. Then of course we don't have any alpha appearing here. Alpha is a dummy index. By our usual raising and lower, this is the same and that. And so we have this is the same thing as minus F rho alpha J sub alpha. Again, if it is our choice, and if we want to, I guess we all want to. This gives us minus F mu alpha, of course, J sub alpha, because we've decided to change our rho to mu. Not because rho is a dummy index, but because if I am making that change anywhere at all, I'm making it all across the equation. I'm changing it both on the left-hand side and on the right-hand side. Now I could change rho here, alpha here, to anything else, n. Of course, it doesn't even appear anywhere else. It doesn't have to. I don't have to affect it here, and it doesn't occur anywhere else. And I guess that gives us this particular expression. So please, just for the sake of the mix-up we had originally, I would like to go through. We've just obtained everything we want to get, but let me just take a few seconds to go through what confusion. Remember, this term alone gave us this. So like I said, you just have to replay that. The first term we had here was F mu, and this is alpha comma nu, and then this is F nu alpha, with nu being directly on top of alpha. And what is the issue here? The issue here was in the process, like I've explained, you can play that backwards. We have to multiply this with G mu rho. In other words, when we did that, of course, we did that, but it's fine. So when we did that, we lowered this mu, and what we had then was F rho alpha comma nu, F nu, and then alpha down. Then of course, by explanation, I can lower alpha and raise alpha here again. And so eventually, this gave me some F rho alpha comma nu, F nu alpha. Of course, along the line, in terms of what we were doing as we proceeded, just like what we did here. Not because rho is a dummy index, we just decided to call rho something else. So we did the same thing in what we did previously, and we changed rho to mu. So that this became F mu alpha comma nu, and then F nu alpha. Now you can see that nu is a dummy index. So just to make it similar to what was here already, we decided to change nu to beta. So this became mu alpha comma beta, F beta alpha. Now, but what we have here is F alpha beta. So we wanted to make this term in every way possible similar to this one. So we will have to change F beta alpha to F alpha beta, and that will give us a minus sign. And that was what I missed initially, and that led us to, well, hopefully this will be very helpful, I hope, and not as confusing as I'm making it out to be. So thank you so much for listening, and I hope we meet again in another set of applications of tensor analysis.